class. This is Mr. Leader here, and today we are going to learn about section 7-6, how to find the inverse of a square matrix and what that means, and solving systems using matrices. Okay, so first off, you have to know what an inverse of a square matrix is, and just like with the algebraic equation, if you have something like 3x equals 27 or something like that, one way you could solve that is by multiplying by 1/3 the reciprocal and multiply this side by 1/3, and you would get x equals 9. Well, an inverse. So the same thing works with matrices. If you multiply a matrix by its inverse, instead of getting 1, which you're getting here, you get the identity matrix. And if you multiply the identity matrix, as we learned the other day, times a set of times another matrix, you get the matrix by itself. So that's what you use to solve systems of equations using matrices. And today we're going to learn about ways to find inverses of square matrices, and we're going to learn some techniques for solving systems using those. Alright, so let A be an n by n matrix and let I sub n be the n by n identity matrix. If there exists a matrix A inversed, that means A inverse right there, such that if I multiply the matrix times its inverse, I get the identity matrix in either order. So if I multiply the inverse times the original matrix, I get the identity matrix, or if I multiply the matrix times the inverse, I also get the identity matrix. And then A to the -1, which is called the A inverse of A, is called the inverse of A. The symbol is red, etc. Okay? Now, not every matrix has an inverse, so not every system can be solved using matrices this way. So if we go to this problem down here, you can see that A and B are inverses of each other. So it says show that B is an inverse of A. So if B is the inverse of A, that must mean that if I multiply A times B, that's an A there, I should get the identity matrix. So let's just do that. If I multiply -1 times 1, I get -1, and 2 times 1 gives you 2, and -1 and 2 gives you a 1 right there in that top left. Now I'm going to take first row times the second column. -1 times 2 gives you +2, and 2 times -1 gives you -2, and +2 plus -2 gives me 0. Okay? And then if I took the second row by the first column, -1 times 1 is -1, and 1 times 1 is 1, and -1 plus 1 makes 0 right there. And if I took this and multiplied by the second row, I'd get 1 right there. It can also be shown that if I went in the opposite order and I multiply B times A, I would also get 1, 0, 0, 1, which is the identity matrix for a 2 by 2 matrix. So therefore I have shown that B is the inverse of A, and also A is the inverse of B. Alright? And again, note that not every matrix has an inverse. So sometimes if you do this on a calculator, you will you'll get an error. Now, I don't have my graphing calculator here at home where I'm recording this, but we're going to do some problems later on where you multiply the inverse matrix times the constant matrix, and I'll show you how to do that. All you have to do is put the matrix into your graphing calculator, and I showed you how to do that the other day, and then you hit the -1 key on your graphing calculator, and that will that is the inverse. So you'll put the matrix in, so you're going to end up multiplying the inverse of some matrix times a 3 by 1 matrix if you're solving a 3 by 3 system, and you will get out another matrix, a 3 by 1 matrix, and that will give you the solution to your system. But more about that later. Okay, moving on. So inverses that do, matrices that have an inverse, matrices that have an inverse are called invertible, and that means they have an inverse. And they don't have an inverse, they are called non-singular. Non-singular means no inverse. Okay? Oops, excuse me, that's wrong. Matrices that have an inverse are invertible or non-singular, and matrices that do have an inverse are called singular. Okay, meaning they don't have an inverse. Don't have an inverse. Did I say that right? All right. So then I cut and pasted some stuff from the book for you. I'm going to close this up here, which I think I can. Come on, buddy. Go. Close. All right. And next thing that we're going to talk about is how do you find the inverse of a matrix by hand. And we're probably not going to make you do a 3 by 3 like they do over here, because this is like trying to get this into reduced row echelon form can be a very complicated, error-prone process, and your calculator can do that for you, okay? But we will require that you at least can find the inverse by hand of a 2 by 2 matrix, and I'm going to show you how to do that. But if you were finding the inverse of a 3 by 3 or a 2 by 2, this is how you do it. So you take the original matrix. I'm going to do an example of the 2 by 2 in a minute. Well, actually, we'll look at this example right here. Write the n by 2n matrix that consists of the given matrix A. So here's the given matrix on the left, and the n by n identity matrix on the right. So you take this matrix and you put it right here, and then you split it up so that it's an n by 2n, meaning there's 3 rows and now 6 columns, where the second 3 columns are the identity matrix. That would 3 by 3 identity matrix, and you write that over there. And then what you do, you use elementary row operations, and you change this part of the matrix into a reduced row echelon form, and then this side changes along with it. For example, if I wanted to change this 1 into a 0, I would probably multiply the first row by -1 and add it to the second row, and that would turn this into a 0, and then this would turn into a 1, and this would still be a -1, but you have to perform the same operations on this row as well. And so this -2, if I multiply by -1, would become, this 1 up here, if I multiply by -1, would become -1 down here, and these would stay the same. So I end up changing this into zeros. This, I had to multiply this by -6 to change this into a 0, then I'd have to change this into a 1, and I keep going, and as I'm changing it, this thing over here on the right changes into the inverse matrix, and that's the inverse matrix over here, which can be seen over here. So if I took this matrix and I multiplied it by the original matrix, which you could do with your calculator or using the techniques that we told you about the other day, okay? 6, -2, -3, I would get the identity matrix over here, and vice versa. If I took this and multiplied by this, I would also get the identity matrix. So I would get 1, 1, 1, 0, 0, 0, 0, 0, 0. Got it? Very good. Hey, you! Yes, you in the back, put your cell phone away. Okay. Savannah? No. Who's got their cell phone out? Okay. Anyway, so those are the steps. If it is not possible, then A is not invertible. And check your work by multiplying A times A inverse and I times A inverse. So we're going to do a 2 by 2 together, and hopefully I can find that here for you. Second, oh, I have it written down. So say that you have this one where A is equal to 1, 4, -1, -3. So my first step would be to write that as an augmented matrix, 1, 4, -1, -3. And I'm going to put some dots right there. And over here I'm going to put 1, 0, 0, 1. Like that, because that's the identity matrix corresponding to a 2 by 2. So now I need to get a 0 over there. So my first step would be to just plain add this row to this row, right? And so if I did that, I'm going to keep the top row the same, 1, 4, 1, 0, okay? And if I add those two rows together, I get 0 here. I get 1, which is looking good. Add this to this, which gives me a 1. This to this gives me a 1, okay? Now I want to change this 4 into 0, and then I'll be done. And so all I have to do that is multiply this row, this entire row, by -4, and add it to the so actually up here I'm going to take row 2 times -4 plus row 1, right? And so if I do that, negative row 2 here, I get 1, excuse me, I'm going to leave the top, no, I'm not. I'm going to change this by multiplying this row by -4. So that times -4 gives me 0, and so this remains a 1. When I multiply this by -4, get -4 plus 4 gives me 0 over there. But you also have to work on this part of the matrix over here. So I'm going to multiply this by -4, which gives me -4 plus 1, which makes -3. And this times -4 gives me -4 up here. And then I'm going to leave the bottom alone. 0, 1, 1, 1. Okay? And this part of that matrix right there, that should be A inverse. And to check that, what you could do is take the original matrix 1, 4, -1, -3, and multiply it by what I suspect to be the inverse, -3, -4, 1, 1, and see if it gives you the identity matrix. So 1 times -3 is -3. Whoops, excuse me. 1 times -3 is -3, plus 4 times 1 gives you 1. And 1 times -4 is -4, plus 4 gives you 0 over there. It's looking good. -1 times 3 gives you 3, and -3 times 1 gives you -3, and that gives you 0 there, and negative 1 times 4 gives you positive 4, and negative 3 times 1 gives you negative 3, and 4 plus negative 3 gives you 1, and you end up with the identity matrix. If I flip-flop those, and I multiplied A inverse by A, in other words, if I put the negative 3, negative, you have to check both directions, 1, 1, and 1 for negative 1 and negative 3. I also get 1, 0, 0, 1. Therefore, this thing right here that I just found is the inverse of matrix A. Now, you could do that with 3 by 3, but it's way, way more complicated and could take like 2 pages of work to do, so we're going to let your calculator do that, and all you have to do to put it on your calculator is just go like that, raise it to the negative 1 power, and it will show up as, it will be the inverse matrix. Okay, and if you're doing operations with it, you could just take the original matrix and put it in as A inverse, just like that. Okay, moving on. So, then, like I said, you can use, there's a shortcut. There is a shortcut for, rather than using the method that I just told you for finding the inverse with a 2 by 2, only with a 2 by 2, there's a shortcut for finding its inverse. So say, for instance, I have, well, here's the formula. If I have a matrix with elements A, B, C, and D, then A inverse, if it does have an inverse, is equal to 1 over, and you all could already learn about determinants. It's really the determinant, AD times BC, 1 over the determinant of matrix A times, okay? What you do is you switch places with the A and the D, so this becomes a D and an A, and then you change the sign of the other 2 elements, minus B, C. So I haven't tried this yet, but let's try it with the last one that we just did, which was 1 for negative 1, negative 3. Okay, so 1 for negative 1, negative 3, and using this formula, I'm going to try to find the inverse of that. So it's going to be 1 over the determinant, which is negative 3 times, or minus negative 4, which gives you negative 3 minus negative 4 gives you 1/7. Is that right? I guess so. I hope this is going to work. Did I do that? Let me go back. 1 for negative 1, negative 3. 1 for negative 1, negative 3. So the determinant is negative 3 minus minus 4, which makes 7, times, I'm going to take the A and the D and switch places, okay? So I'm going to go put the negative 3 up here, and put the 1 down here, and then I am going to make this sign negative, and I'm going to make this sign the opposite of what it was, which was, D minus B. This should be minus C over here, okay? And so this becomes a 1, and now multiply through by 1/7, and I get negative 3/7 minus 4/7, 1/7 over 1/7. And Okay, so teachers make mistakes sometimes. Negative 3 times plus 4 is 1, not 1/7, and that's why I wasn't getting the same answer. I just get 1 over 1, right? Negative 3 plus 4 makes 1, so that's 1 times this, which is just the original matrix, which is what we got in the last problem. So sorry about that. You were probably yelling at me as you were watching that, but I'm not going back and changing the video. Alright, so now, how do you solve systems using matrices? It's pretty easy, and so the formula is X, which is the matrix consisting of the X of the solutions. This is a solution set. All you have to do is go multiply the inverse of the coefficient matrix times B, which is this is the constant matrix, okay, and this is the solution. I guess we call this the solution or variable matrix, and this is the coefficient. And why does that work? It works because if I take some matrix A and multiply it by X, okay, that we already rewrote matrices, that's equal to the constant matrix over here, right? Now to get rid of this A, I multiply by the inverse, okay? And if I multiply one side by the inverse, I have to multiply the other side by the inverse. And this A inverse times A becomes the identity matrix, and the identity matrix times X is equal to X, so you end up with X is equal to A inverse times B. So, for example, say I am told to solve this this particular system of equations, right over here. So say I have 2x plus 3y plus z equals -1, and 3x plus 3y plus z equals +1, and 2x plus 4y plus z equals -2. The way you solve that with matrices is you rewrite this as a constant matrix, okay? Coefficient matrix 2, 3, 1, 3, 3, 1, 2, 4, 1 times x, y, z. Oops. 2, 4, no, that's right. Times over here, I'm going to put times x, y, z, okay, and that's going to be equal to the constants over here. -1, excuse me, sorry, it's late, 2, -1, 2 over here. Alright, so now to get rid of this, I'm going to multiply this by the inverse. If this we call matrix A, I'm going to multiply this by A inverse, which is whatever the inverse of that is, and then we'll make that disappear, and I get x, y, z, and I have to multiply this. That's a 3 by 3, even though it doesn't look like, by the inverse of that. So x, y, z is going to be equal to A inverse, in this case, times the matrix +2, -1, and 2. And if you do that on your calculator, you get, oh brother, it's late. Constant matrix is -1, 1, and -2. Sorry about that. And the answer, this is -1, 1, and -2. And the answer over here is 2, -1, and 2. So this is x, y, and z, which is a solution to this system. Now, if you try to do this and you get something like mismatch or something like that, it means that this matrix that you're trying to solve doesn't have an inverse. Okay? And so therefore you can't solve this system using matrices. Either it has no solution, or it has infinite solutions, or you have to find the solution some other way using elimination method or something like that. Okay, so your homework is, let me find it on my website. I'll just pause for a second. So, whoops, sorry, I guess I didn't pause. Oh, this is a bad video. Anyway, this is your homework, and I'll talk more about it on Monday, and that's on my assignment sheet on my webpage. Okay, have a nice weekend, do your homework, and root for the Broncos next year. Okay, bye.